section 2.5, adding and subtracting fractions. Now, adding and subtracting fractions are going to be probably the most difficult concept to get in terms of the course and all of its pieces, but I'm hoping to show you a really easy, efficient way of doing this, just like we've done with the rest. Well, let's look at a fraction. Okay, let's look at 3/4. What the 4 tells you is the grouping. We've talked about groupings before. Remember we talked about groupings of the tens place? Well, now we're looking at a fractional component. So this tells you the grouping here is a 4th. What the top number tells you, the 3, tells you there's 3 of them. So what you have here is, if you look at this, you have 3 1/4. So the grouping is 1/4, and then 3 on top tells you have 3 of them. So let's look at an example here. This will be on page 116. It's example 1. It's 5/16 plus 7/16. Now when we look at this, let's go back to, we've talked about this many times and it'll show up again, the basic rule of addition. The basic rule of addition stated that you can only add things that are alike. We've talked about that many times. Well, let's look at the grouping here. Look at the grouping of 16 and 16, so you can add these together. So the way we add them is, the grouping doesn't change. You still have things cut into 16ths, for example, but now you have 5 plus 7 of them. You have 12 of them. Now, this goes back to what we learned before. All fractions must be reduced, so keep that. All fractions must be reduced. So now that we have this, all fractions must be reduced, we'll go back to what we learned before. We'll prime factor 12 and 16. 2 goes into 12/6. 2 goes into 6/3. We can stop. This is stuff we've worked with already, right? 2 times 2 times 3 is 12. 16, 2 goes into 16 8 times. 2 goes into 8 4. 2 goes into 4 2. And we stop. So 16 is 2 times 2 times 2 times 2. Then we cancel, and we get 3. 2 times 2 is 4 3/4. So when you add 5/16 plus 7/16, you get 12/16, but when you reduce it, you get 3/4. Okay? So that's an example of doing them when the denominators are the same. Because they're alike, you can go ahead and add. Now, the most difficult one, and the one we'll see moving forward, this is actually on page 118, and this one will be example 2. What happens if the denominators are not alike? 7/15 plus 3/10. What happens if they're not alike? Well, we can't add them together because 15 and 10, they don't add up. It'd be like if we had a pizza cut into 15 slices and one into 10. They're different. They don't give the same in each piece. So what we need to do is we have to come up with a least common denominator. We're going to come up with a least common denominator, so LCD. And sometimes students can look at this. I'll have students, I'll say, hey, look at this, tell me what you think. They'll give me all kinds of answers. I've had 5. 5 is their greatest common factor, which I'll put off to the side here. That's the GCF. That's something we'll work with later. Or they'll say, oh, somebody will shout out 30. And then we'll say, okay, great. And then some students are like, we've done this before. They're like, there's no way I would have known that was 30. And that's okay. So I'm going to give you a step-by-step. It's going to be 4 steps here. I want you to do a 4-step process here when you're finding like denominators. The first thing I want you to do is prime factor the denominators. Prime factor the denominators. Okay, so let's do that. We just go off to the side and do this. Alright, so we have 15, we're going to prime factor, and 10. Alright, 2 doesn't go into 15, but 3 does 5 times. 2 goes into 10 5 times. We prime factored these. So the first step, and I'll put it down here, I'll put a 1 here. the first step you can see is I want you to do 7 and then do 3 times 5 on bottom here. And then you have 3 and you have 2 times 5 here. Okay. Notice you don't do anything with the numerators, just prime factor the denominators. Okay, then the second step is I want you to determine which factors they have in common and which ones they don't, and then make them look the same. So what we're going to do is we're going to effectively make sure the denominators have the same factors. Now, what I want to show there is if we make sure that they have the same factors, notice here, this one has a 3 and a 5, this one has a 2 and a 5, so they have a 5 in common, that's okay. This one has a 3, this one doesn't, so I need to give it a 3. This one has a 2, this one doesn't, so I need to give it a 2. So notice I'm putting them in red so you can see what I added. So now look, this one has a 3, a 5, and a 2. This one also has a 3, a 5, and a 2. So the second step there is make sure their denominators are the same. Now the third step is whatever factors you put on bottom, you can see you put a 2 and a 3, then also put the same factors in the numerator. So notice in step 3, and I'll put a 3 up here so you can kind of see it. You put a 2 here, you need to put a factor of 2 up top as well. You put a factor of 3 here, you need to put a factor of 3 here as well. So notice, first step, prime factor, then find out what's missing and put it in each denominator so they have the same, and then put the same up top. Now the fourth thing I want you to do is just put it together. Put it back together. Now notice what we do here, the fourth step. 7 times 2 is 14. 3 times 3 is 9. 3 times 5 is 15, times 2 is 30. And then 2 times 5 is 10, times 3 is 30. So you can see how we get 30. They have the same factors now. So now, when you get to this step here on 4, isn't this exactly what we just showed in example 1? You can add those together, finish the problem, just like you did before. Just really quickly, 14 plus 9 is 23 over 30. Then you try to reduce. Now in this case here, 23 is prime, but I want to show you what's really cool about this is the denominator, when you do this now, you already have the breakdown of the denominator. It's up here. So the denominator is one of those. You can use the 3 times 5 times 2. So that's always right here. That's kind of a cool thing, is that when you go to reduce this, you already have the denominator broken down up here, so you don't have to redo it. And then you do the top. Now if we just real quick go through 23, 2 doesn't go into 23 because it's not a 2, 3 doesn't because 2 plus 3 is 5. We don't have to try 5, remember, because 5 times 5 is 25, so we're done, so this has to be prime. So that's how we knew, and then you see nothing happens there, so the answer is just 23 over 30. What's really cool about this method as well, if you follow this 4-step method, is it also works for subtraction. The only difference is there'd be a minus sign here. Okay, just real quick, what I'll show you there is, what if this was subtraction up here? What if we had 7 over 15 minus 3 over 10? The exact same procedure would happen. You would get 14 over 30 minus 9 over 30. Now if you did this one, then you'd get 5 over 30. And then this is interesting because on this one, if you did it, you would have 3 times 5 times 2, and you would be able to cancel the 5s. And you'd be left with a 1 on top, and then 3 times 2 is 6. So this is addition and subtraction of fractions. It might have been more difficult in the past, but now it's not, with this nice 4-step procedure that I want you all to follow and break numbers down with.